Cubic functions don't have absolute maximum and minimum points, but I did want to go through a few examples where we are identifying for cubic functions the maximum or minimum on a given interval. So we're going to start by looking at a graph of the parent function. This is f of x equals x cubed. And we will start by finding the maximum on the interval from -1 to 1, including the endpoints. So I'm going to start by shading my graph so I know what interval I'm looking at. So I'm going to draw vertical lines at -1 and 1 and shade in between. So in this yellow shaded region, what is my highest point on the graph? And it looks like it is this point right here, which has the coordinate 1, 1. So I could say the maximum point is at 1, 1. And the maximum value is the y value, 1, at x equals 1. So if I want the maximum point, I'm going to give a coordinate. If I want just the maximum or the maximum value, I'm giving the y value. So let's also find the minimum on the same interval from -1 to 1. So in this yellow shaded region, what's my lowest point on the graph? And it looks like it's right here at the point -1, -1. So I could say my minimum point is -1, -1, or my minimum value is the y value, -1, at the x value of -1. Okay, let's look at another graph. This is a graph of a cubic function, but I don't know what the equation is. And for this, we will find the maximum on the interval from -1 to 1. So just like before, I'm going to draw vertical lines at -1 and 1. I'm going to shade everywhere in between in yellow. And I'm looking for the maximum point on this interval. And it looks like it is right here at the origin, or 0, 0. So I could say the maximum point is at 0, 0, or the maximum value is at 0 when x is 0. Okay, finally, let's find the minimum on the interval from 0 to 2. So I'm going to draw another shaded region. I'm going to draw vertical lines at 0 and in 2. I'm going to use green for this. And then I'm going to shade in between them using green. And in this green shaded region, I'm looking for the minimum point, which looks like it's here. And I don't know exactly what this value is, so I'm going to approximate that y value. It looks like it's about at 1, -1.2. So that -1.2 is an approximation because I'm not exactly sure what its exact value is. So I could write the minimum point is at 1, -1.2. The minimum value is -1.2 at x equals 1.